All right, welcome back to Math's Easy, step by step. In this part 62 video, we're going to continue to multiplying fractions in decimal form. Hey, what's the first thing we need, right? We need some fraction values that we can convert into decimal form. All right, as you can see here, we have 2/3 times 1/5. And this is really saying every fraction is a division problem, right? And this is really saying 2 divided by 3 or 1 divided by 5, right? So I'm going to convert these fractions into decimals. Let's get her done. All right, so 2/3 is 2 divided by 3. Showing your indivisible decimal to the right of the 2, raise it right above that divisor bar. So 3 times what number? Whole number gets me closest to 2 without going over. There is none. So there's a 0 right here in the placeholder. So that 2 will now become a 20. 3 times what number gets me closest to 20? 3 times 6 is 18. I'm going to subtract 18 from 20. That gives me a 2. Bring down the next digit. That's 20. So 3 times 6 gives me 18. Closest to 20 without going over. Are you seeing a pattern here? 20 minus 18 is 2. Bring down the 0. 20. 3 times what number? 6 gives me closest to 20. And that is 18. So I'll subtract 18 from 20. That gives me a 2. Bring down the 0. Oh, it's another 20. 20, 20. So if you're looking at this pattern, you're seeing that the value of 6 repeats over and over and over again. 6 will repeat on and on and on and on until you round it up to a 7 eventually. So the little indicator above the 6, this little mark here is telling you that, hey, this 6 is going to continue to repeat over and over and over and over and over again. So understand that's what that means. So 2/3 is equal to 0.666. Okay, so 1/5 is 1 divisor bar 5, or 1 divided by 5, like you see here. To the right of 1 is invisible decimal. I'm going to show it and raise it right above the divisor bar. Now 5 times no number, 0, will get me 1. No whole number will get me 1. So that 1 becomes a 10, right? And I know 5 times 2 is 10. I'll subtract 10 from 10, I get 0. Bring down my other 0. 5 times 0 gets me 0. Bring out the other 0. 5 times 0 gets me 0. And on a million times. You can put a million zeros behind that 2. And it's still going to be 0.2 or 0.20 or 0.200. I'm going to keep this as 2/100ths or 0.200. And I'm also going to show you what it looks like when you multiply just 2/10ths, 0.2. All right? You're going to get the equivalent values. But for right now, I'm just going to keep it 0.200 or 2/100ths value. So 1/5 is equal to 0.200. Okay, I want to put these fractions side by side just to clarify a little bit. Again, 2/3 is equal to 0.666 thousandths, right? These are equal values. They're just written in different forms. One's a fraction, one's a decimal. 1/5 is equal to 2/100ths or 0.200. Okay, again, fraction, decimal, but they're both equivalent values to each other. All right, so let's take both of these decimal values and let's multiply these values, these fractions, as decimals. Let's get her done. All right, so we've completed step 1. We've turned the fractions into a decimal. Step 2, do we really need to stack the decimal values? Do we need to line up? Let me say this again. We're going to stack the decimal values, but do we need to line them up like we do when we add or subtract? Well, take a note. It's not important to keep decimal values lined up like when we add and when we subtract decimals, right? You don't need to line them up, although in this example they'll be lined up. But I have a second example with the same two multiples where they don't line up, because I want to show this is an important point, right? You're counting the values or the digits to the right of the decimal. You're not stacking them up like you do when you add and subtract. Okay, so what's important is that you're counting the digits to the right of the decimal, right? There's 1, 2, 3, 4, 5, 6 total digits to the right of the decimal. That's what's important. You need to keep that in mind before you finalize your answer, right? Remember, you got to do something a little bit special. So, hey, let's just get to multiplying. Okay, so anything times 0 is 0. 0 times 6 is 0, right? 0 times 6 are 0. There's one thing I want to show you. Before I can multiply with this second 0 is I have to put a placeholder. I'm showing it in red so it stands out before I can start multiplying. 0 times 6 is 0, right? So before I multiply with this 2 times 6, what do I have to do before I can start doing that? Do you remember? All right, shoot, you got me. You're on top of it. You add 2 placeholders before you can multiply that 2. And let's just get through it. So 2 times 6 is 12. I'll put the 2, I'll carry the 1. 2 times 6 is 12, plus 1 more is 13. I'll place the 3, I'll carry the 1. 2 times 6 is 12, plus 1 more is the 13 you see here. Now, I'm going to add all of these digits. They're all lined up nice and pretty like. I'm going to add them up. And what do I do with my final answer? If I've got 6 digits to the right of the decimal, what am I going to do? All right, you said move your decimal to the left 6 times. You're absolutely correct, right? So there were 6 digits to the right of the decimal. In our final answer, we're going to show the invisible decimal here and move it 1, 2, 3, 4, 5, 6 times to the left before we can give our final answer. 6 times to the left. And so our final answer in this problem will be 0.1332. You can add those zeros or not. I'm going to show you in just a moment what you would get if you just multiplied the 0.2 times 0.666. Let's check that out. All right, so some of you are saying to yourself, listen, we didn't need to add the 2 zeros to the right of this 2/10, right? We could just multiply with the 2/10. And you're absolutely correct. And that's why I want to show both methods. You're going to come up with the exact same answer whether you do or you don't. So we have 1, 2, 3, 4 digits to the right of the decimal in total, right? In total. And again, 2 times 6 is 12, carry the 1. 2 times 6 is 12, plus 1 more is 13, carry the 1. 2 times 6 is 12, plus 1 more is 13. Now, since we had 4 digits to the right of the decimal, we're going to move our, show the invisible decimal, move it 1, 2, 3, 4 times to the left. You end up with 0.1332, just as you did a moment ago. All right, so I wanted to show you that either way, 0.1332 is equivalent or equal to 0.133200000. These zeros go on and on and on forever, right? They're just placeholders, but both of these values would be exactly the same. So again, our final answer, 0.1332. Math is easy. Take it step by step. Stick around. I have some more examples for you. Thank you for joining me. I appreciate your time. Please like, follow, share, subscribe. If I've helped you, please help me to help others.